There. Oh shoot! Now, hang on a minute. It's not letting me do what I want to do.
Well, we're live now, Tim.
Okay.
Well, good morning, good afternoon, good evening. We are doing another episode of the LMTV Sharkfest, and the reason for that is that Monday or Tuesday next week is the beginning of the Wireshark Development and Conference, and all of us are very excited to be part of that. And there are a number of sponsors, and some of which are actually co-sponsors of both Wireshark and Sharkfest and Love My Tool, and one of that company is Datacom. So today is with great pleasure that I invited that Tim Crofton, who's the VP Operations of Datacom Systems, have accepted our invitation and our challenge actually to talk about something that should be of interest to all of us, which is network taps. Right. Good evening. Good afternoon, Tim. How are you?
I'm great, Denny. Thanks for having me on. I appreciate it. How are you, Tim?
Still alive. Even at this age, I still keep kicking.
Well, Tim O'Neill and I, we talk a great deal about tabs on Love My Tool, and it's surprising to me that after all these years we still talk about tabs. Mm-hmm. And I think that it is important to talk about it, and I think that especially in relationship to Wireshark, and I think of Wireshark as a DNA tool, and I think of the tab as someone that basically deliver chain of evidence. Right. I mean, how good is the tool when the data itself is suspect? So so with that, I'm going to turn to Mr. Crofton and let him kind of share with us some of his perspective.
Great, thanks, Denny. Thanks, Tim. I appreciate being on LMTV again. And as you said, since we're all very excited about Sharkfest starting next week, Datacom Systems is an angel sponsor. It's our first time sponsoring at Sharkfest. So I wanted to have a presentation that combines the concept of Wireshark and how a lot of our customers use Wireshark, along with one of our product lines, which is network taps, and actually demonstrate how we use those two devices together and how that can make a difference in your monitoring of your applications and security and compliance type things within your network. So that's the kind of presentation we've put together today. You'll see a little bit of Wireshark and some of the best practices that we have for deploying network taps in your network.
And just make sure that our audience understand that Tim will be in San Jose next week, and he look forward to having quality conversation with some of the attendees. And today is just sort of laying the groundwork for that, right, Tim?
Yeah, today is really just to go over some of those best practices, and we hope that this will be really an educational topic for customers so that they'll understand a little bit more how to deploy taps and why they make sense to be used in their networks.
Okay, go ahead.
All right, so am I sharing yet?
Not yet.
All right, let me get the right one up here. How's that?
Perfect.
Got it? Okay, great. Mm-hmm. So we're talking about Wireshark and taps together, so we kind of coined the double shot term. If you're trying to run business applications on your networks, these are two great things to have. As I said before, I would say probably 99% of our customers have Wireshark deployed in some way, shape, or form, along with some commercial tools, obviously. But we'll show some Wireshark captures in today's presentation. So just some introductory things for some new users out there. We use the term spans, or AKA port mirrors, or taps, and we use those to gain visibility into the packets that are running through our computer network. What do we do with those things? We hook them to our analysis and security devices that need to see these packets in order to do their analysis. And we have to understand the differences between these different types of collection methods. So port mirroring or taps, what's the difference between them? When do I deploy them at which times? And what's the good, the bad, and the ugly of those different ways to collect information? And all of those really combine to give you the best visibility into your network. So we'll take a look at those things today. First, a couple of definitions. We're going to use mainly the term switched port analyzer, which means the acronym is SPAN, or port mirror interchangeably. I use SPAN basically because it's shorter and easier to type. And everybody, I think, that's been involved in networking, but for some of the new users, a port mirror mirrors packets from one port on a network device to another. It's often routers or Ethernet switches and things like that. SPAN is a software implementation. It tells the device to mirror these ports from one to another, but it does require administrative access, and it uses some of those internal device resources in order to do that processing. So that's really what a SPAN is. And here's an example picture of how we've taken traffic that's going from a workstation through an Ethernet switch to a router. We've built a SPAN port on that switch via software by logging into the Ethernet switch, and we're saying, please send a copy of traffic that's going to this workstation or going to this router. Send a copy of that over to our monitoring device. Very often that monitoring device, as we stated earlier, is Wireshark running on a PC or running on a laptop. So that's what a SPAN is. What's a TAP? A TAP, the acronym some people will use, Test Access Point or Test Access Port. It's a physical device that provides access to the data running through the computer network. And it's a hardware device. It's inserted into the network. It allows packets to flow through the device, and it makes a copy of those network packets for analysis. Now, I have to pay homage to Tim O'Neill, who's on this call, because I think Tim has probably the most popular document ever written on the subject of do I use a TAP or do I use a SPAN port, which is one that he wrote for Love My Tool. What was that, back in 2009, Tim? 2007, okay.
Yeah.
Yeah, so it's been a very popular topic, and people are, I know, come back to you from time to time to add on to that and dial in some more questions.
On a regular basis.
All right. So here's a copy of a physical diagram of where we show the router, firewall, and then a tap that we've inserted in between. Notice it allows traffic to flow between the router and the firewall, and at the same time it's making a copy of that traffic down to the analyzer. Now, we're not going to go into all the details about what a tap does, and there's a bazillion different kinds and things like that. We're really going to focus on using Wireshark and some of the benefits that a tap can provide you. But as Tim knows, one of the most common questions people get asked is, what happens to my tap if it loses power? In this slide, I just wanted to include this to show customers that if it's a copper-based tap, every copper-based tap that's deployed has some type of a failover mechanism so that the router and the firewall are directly connected if the tap loses power, as you see on the right-hand side. When the tap is operating normally, it may operate as you see on the left, where it's making a copy of the traffic. It can aggregate traffic, it can filter traffic, it might load balance traffic, but it can do a variety of different things. So I wanted to make sure that customers understood there are mechanisms with taps so that it allows traffic to flow through the tap even if it's there's a loss of power. Now, as many people know, with fiber taps, it's not a consideration because the fiber tapping mechanism doesn't require power at all to achieve that same goal.
And Tim, one thing I'd mention is a lot of people ask that question, but I've never been in a network where they had, when the network went down or the power was lost, they had the time to worry about the tap. They were trying to figure out why the power was down. And
right.
Very seldom do I see, if that's a worry, plug it into your UPS system.
Right, that's right. That's right. And I would say that most manufacturers have redundant power supplies for their taps. As long as you connect those redundant power supplies to separate circuits, that also minimizes it. And in my 10 years of experience, I've never seen an issue where both power supplies failed simultaneously. Right. As long as they're plugged into separate circuits, you're in good shape.
Yeah.
So why do customers use SPAN? It allows you to see intra-switch traffic, so you can see on a SPAN port, you can see the traffic that's running inside of that network switch or router. You don't really have to install anything. You've already bought it. It's built into the device. You can implement it very, very quickly, and it's great for short-term troubleshooting. If you just want to go into a box without messing around with anything else other than the device configuration, it's right there. Why do customers use TAPs? It's really, there's less risk of random packet loss, and we'll take a look at that in just a second. There's really not a complex configuration. A lot of the TAPs out there are very, very simple. And then they give you access to very key links which leave the span ports free for other types of troubleshooting. And one of the comments we do need to make is that the number of mirror ports available on network devices is typically limited. So you can have multiple implementations on many devices, but sometimes you want to reserve those for other types of troubleshooting, and the TAP allows you to do that. And of course, I have to put a copy of one of my favorite movies of all time, Spinal Tap, because when I tell customers or tell people that I know, oh, I make taps, they're like, oh, have you seen Spinal Tap? That's like my favorite movie ever. I'm like, no, 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 not that kind of tap. Not that kind of tap.
And one comment, just supporting what you said about limited number of span ports, not only are they limited in quantity, they usually have an existing owner.
That's correct, yes.
So if you're the security guy and you want to get access to the span port, which belongs to a different group, good luck.
Yeah, that's true. We want to be able to share that network traffic amongst different departments, and that's maybe not easily done when you implement spans on your network devices. But just to talk about the complementary aspect of spans and taps, they really are used together. And if we can just go back to the slide, you'll see that they really both provide you visibility. The span more into the backplane of the device without any really essential cost to implement, and then the tap giving you different visibility, providing you access to different types of traffic, as we'll take a look at here in just a second.
Yeah, as long as you're not trying to do something with a time-relevant study,
right,
or below layer 3, SpanPort can help you, but don't believe it. If you're looking at real-time protocols, voice over IP, video over IP, it grooms the packets too much. So you'll look at it and say, oh, everything is wonderful, and then it's not, because a SpanPort, and by the way, a SpanPort was an absolute incredible marketing tool put out by Cisco. It was actually a test port originally that marketing said, let's make it into something they can actually use. And I probably 90% of the time I would never use a SpanPort because I want to know really everything that's going on from every bit, every interframe gap, even bad packets. I want to see all that, where the SpanPort won't allow you to do that.
That's right. That's right. So customers will often choose a tap over a span for a couple of different reasons. One, they're as we said before, they're limited on the number of span ports they have. They're easily modified, so if I'm doing some security analysis, I may not want another person who has access to that device to go in and turn off or change or modify my span port. We find that a lot of our customers have a change control policy that doesn't allow them to go in during the day and make changes to the network configuration or only during maintenance windows. And Tim, as you said, the span ports were originally designed as a diagnostic tool and really wasn't designed to be a long-term analysis port, although many customers do use them successfully today. But originally it's just kind of a go in quick, do some analysis, and turn it off when you're done type thing. And you do need taps that are deployed typically where you want dedicated access. The most common places we see taps deployed are right behind the firewall or just in front of very critical core servers, or basically anywhere you get into or out of your network. Points of ingress or egress is typically where we see a lot of taps deployed, and in complement with using span and mirror ports as well.
And the best time to install a tap is at the beginning.
Correct.
When you're actually deploying the network for the first time, that's the time to do it.
That's correct. The analogy I always use, Denny, is it's kind of like building an engine for a car and not putting a place to check your oil. So after you built the engine, you're like, oh, I don't have a place to check the oil now. Where do I check the oil? And you have to go and retrofit something. And we see that quite a bit with customers.
And by the way, I mean, just go along with the analogy is that span port is like checking oil by looking at the exhaust fume.
Yeah.
I mean, it does the job.
Yeah, sure. Or listening, I guess, listening to the engine. So a couple other nice things about taps is that we typically don't want them to become a point of failure, so they're designed to have some resilience to them. We want them to have minimal latency because they're put in line in the network. They're going to give improved visibility, as we'll see in just a second. They are secure, and a lot of the taps are non-managed devices, and the traffic is typically unidirectional to go to the monitoring ports. Many of them have no configuration, and they'll overcome some of the span limitations that we'll see in just a second.
And a tap is absolutely the only piece of network equipment that cannot be hacked. Okay? If you're in security, you want to look at what's really going on, get a tap.
That's right. Yep, it's one of the best security tools out there. So here's the test scenario that we run in our lab, and you'll notice that we've combined it with the use of Wireshark. We've got two network devices, a firewall and a network switch, and we're going through a tap, and the tap is making a copy of that traffic and sending it to a tap monitoring device, which is running Wireshark. And then the switch has got a span set up or a port mirror set up, and that's going to another device which is running a Wireshark. So I just wanted to show this so that this is the test scenario that we set up, and we're going to look at the output. We're going to see first what network traffic is on the network, and then we'll look at the network traffic, what the span shows you, and then what the tap shows you. So got a few examples here which I think you guys will find interesting. One of the first ones, and one of the most common ones going way back that some of us old guys will remember, is that the span ports will often strip VLAN tags. So if you go up to you look at the top of the screen here, you can see that we've got VLAN tag packets because they are 78 bytes in length. That's identified by the network traffic over there in the upper right-hand corner. So that's the network side. And then we go down to the middle part of the screen. We see the span monitoring, and we see that that packet has changed from 78 down to 74. So the 4 bytes of the VLAN tag have been stripped by the span. And you look at the bottom, you see that the tap actually allowed the VLAN tag packets to come through. It's 78 bytes. And if you look way down at the bottom, you'll see that if you look at the bottom of our Wireshark screen, what's great about Wireshark is it shows you all this detail. You can see that it's an 802.1q VLAN, and you can see that the actual tag is 187. So that's the VLAN tag.
And by the way, the reason why SpanPort strips VLAN is because it's a feature, not a bug. That is in fact how SpanPort is implemented.
That's right.
Is by having its private VLAN.
That's right. Yep. So if you want to see those, a tap is a great way to get visibility into those VLAN tags. It shows you really what's out on the wire. Okay, the next slide talks about jumbo packets. And in the top of the slide, you'll see that we basically took different packets and we increased the size of them by about 512, I think, bytes, and just continued to go up and up and up and up and up as we were generating traffic. The middle slide shows you that the span after 1320 bytes stopped sending traffic onto our Wireshark device. But on the bottom of the screen, you'll see that the tap kept sending jumbo packets all the way up to as far as I think we went, which was 9,000 bytes. So again, different taps are going to operate in different ways. Some are going to send larger packets or smaller packets. So it's, again, for people out there that are considering using taps, understand the limitations of the byte size of your span or your port mirroring and understand the limitations of the taps that you're deploying as well. But in this particular case, the span stopped at between 13 and 1800, and the tap continued to go on and on. So again, just making sure that people understand the differences between the two. And if you want to see those larger style packets, make sure you test your span and test your tap to make sure what they're both capable of. And then our next example shows that we basically had an out of order occurrence. So the network traffic, we were sending out TCP and LDAP packets, and you can see in the middle of the screen the span actually had an out of order TCP packet, and Wireshark very conveniently displays that and highlights that in black for us. Again, thank you Wireshark and all the developers out there for making these great features that make it easy for us network types to troubleshoot. And if you go to the bottom of the screen, you can see that the tap output is essentially a mirror of the network traffic. So the tap, again, very closely aligned to that. There can be out of order issues with some implementations of span. Depends on how busy the switch is, how much processing it has, buffering, the packet environment, the interframe gaps, and all those kinds of things. So just moving along to when you're going to consider using a tap. I certainly not the type of person that would say a tap is going to solve every problem you've ever had. Be aware that a copper-based network tap may bounce your network if it loses power. There's relays in there that will, again, make that physical connection as we showed in our previous slide. If maintaining that network connection is absolutely critical, then convert that link to a fiber tap or use a fiber tap in that link. And going into the differences between copper and fiber taps is, I think, beyond the scope of what we want to do today. But there's plenty of information out there on various websites to talk about the benefits of doing that. A tap may not show you a malformed or a pause frame. It depends on the type of tap, depends on what it's doing. So if there's physical errors with the packets, the tap may not show it to you, but a span port may not show you errored packets either. So be aware of that type of consideration. As Tim mentioned earlier in the presentation, you can lose some clocking. You can have some delay when you're going through a network tap. So be aware of that criteria and do some good testing up front before you deploy those devices. So I wanted to have kind of a side-by-side for the advantages for each solution. Taps, obviously, you don't have to use a physical port on your network device. It gives you, as we saw in this presentation, some visibility that the span port doesn't. And as we talked about with security, it's essentially invisible to the network. You don't see that the network tap is deployed. They don't have MAC addresses on the ports. The traffic is unidirectional. And in many of the simple taps, there's no management access to them, so they can't really be hacked. The span and the mirror ports, they give you backplane visibility. They doesn't require an extra hardware purchase. You can implement them very quickly and really don't have to have any kind of planning or anything if you choose to implement them, versus taps you're going to do testing, you're going to make sure they're deployed properly, you have to know who has access to them and all those kinds of things. So from a best practice standpoint, you want to make sure that taps are certainly part of your application security and compliance monitoring solution. Span and mirror ports are part of that, along with looking in your log files, your syslog files, and there's a variety of different applications and tools to do that. Being aware of your NetFlow, your IPFix, JFlow, NetStream, AppFlow type information. Do SNMP monitoring. Certainly do network management with a variety of products that are out there to do that, as well as using distributed probes and analyzers that are both inline and out-of-band devices that can do specific application style testing. So want to make sure that people understand taps are a component of a best practice to do better application and security monitoring on your networks. So
a highly desirable piece of that.
that's right. That's right. Oh, I got to go back to my other screen.
One of the things I always tell people is span is a nicety, but it wasn't really designed to handle today's networks. It's got a bus, and it's just like we talk to people about when you run a software package in a PC. Remember that PC's running on a bus, and it gets interrupted periodically too. So
sure.
you may not get the full capture there, but from my perspective, well, I know for a fact because I do this, but Kalia, WISPA, almost all of these standards today are saying span port is not acceptable. Neither are VACLs or embedded protocol captures acceptable for that level of monitoring and analysis. And of course, and we just saw recently where Cisco, Ubuntu, a bunch of companies have had their operating systems hacked and breached.
Right.
And they just yesterday they just announced that they about 80% of our solar farms and wind turbine groups have been hacked. And it's I want a device from my perspective, and several of the people we have on Love My Tool, when they go out and do stuff, they said, I'd rather have a tap because I know I'm getting everything that's going through that network. I'm not losing anything, and I'm not exposing the network to any kind of potential disaster. And I did a study years ago. I wrote an article and put it on Love My Tool, and I wrote a span interface, simple one, just to capture an IP address. And I think that's been up there for 6 or 7 years now. And I purposely put 2 mistakes in there, major mistakes. And to this day, no one has ever said, Tim, that wouldn't work. So it can be, spans are great if you're right there. You want to do a study on what
sure.
IP addresses are connected, studies that don't involve time. But I'm
sure.
a purist at heart because I'm an old guy. And I helped build the first span or the first tap back in the 70s for V24 or RS-232. Yeah. I'm a purist. I want to see everything.
Sure.
I don't want anything going missing. And with e-discovery and all the new demands on that, man, I would tell people, spend a little money, get a tap. And especially one of the great points you put out, put a tap between your WAN and your your security wall, wherever that's at.
Right.
And that's, people now are beginning to realize, now I can see what people are trying to attack me with. Are they using port scans? Are they using sync pulses? Are they mucking with my DNS? Are they trying to poison it? And you won't be able to see that behind the firewall. Hopefully.
Right.
You won't be able to see it behind the firewall.
Right.
If you see it behind the firewall, you got big problems. You've been hacked.
And what's easier than walking up with a implementation of Wireshark, plugging into a tap that's just sitting there all the time? You can see exactly what's either, as you say, in front of your firewall or behind your firewall in an instant. And it's a very, very cost-effective way to see what's going on in your network.
Absolutely.
Yeah.
I don't know if you heard about the massive Karnak hacks that 30 countries stole roughly $1.5 billion. We think no one's telling us all the finalities. If just one person in a bank had a tap in between anything in there, he would have been able, or he or she would have been able to see the massive amount of traffic that was not usually going out of their network and coming in. They would have seen commands coming in that they never have seen come in from outside.
Right.
Just one tap, one person monitoring his network, understanding his network, they would have saved a lot of money.
Or even customers that are just using the tap as a collection device to feed it into a storage device, so that if there is an issue, what they can do is go into that storage device and rewind it and see, again, we tried to demonstrate in the presentation today how a tap will give you better visibility to the type of traffic that's out on your network. And so you can kind of dial back to that storage device that's hooked to the tap and say, oh, I can see the attack started at this particular time and it lasted this long, or here's the instance where this malware got into my network. And again, because that tap is physically isolated and typically locked up. No one can go in and reconfigure it unless they have physical access to the closet or the physical location. So it's, again, a great way from a compliance standpoint to be able to make sure you can rewind and see exactly what happened for root cause analysis and prevent that from occurring again.
I concur wholeheartedly. I tell people, if you can't see it, you're not going to know it's broken. You're not going to know how to fix it, okay? And you're not going to be able to say, I don't know what happened. And when you say that, guess what? Nowadays with the FTC, if you've had a breach and they say, how many records did you lose? And you said, I don't know. They assume you lost every record. Therefore, the fine reflects that. So $1,000, $2,000, $3,000, $20,000 worth of taps can save your company a lot. And now the insurance companies have recently announced that if you're not making best efforts to protect your network, you're not training your users, they basically said we're not going to be responsible for dumb, both dumb in the operation sense and dumb in users, because that's where a lot of our breaches occur. So
yeah, and as we said, Tim, because they're, one of the things hackers try to do if they do get into your network, they try to cover up their tracks. They try to erase your log files or any of your monitoring. And with a tap, the tap's invisible to the network. It doesn't have a MAC address. You can't see it, whether it's a copper tap or a fiber tap. So they don't know that they're being monitored. They can't get to the monitoring device or the record to erase that. So again, it's a very sound security policy is to have that inline device, which is unidirectional to the storage, especially in front of those critical servers. We see them a lot in front of database servers and intellectual property, even email and things like that. So they know all the traffic that's been going in and out of that device, and they have a record of it that can't be modified.
Now, we had a situation here where they had been monitoring our network with best effort, but something was wrong. And they asked me to come out, so I came out, I got an old tap, and I plugged it in, and it took me about 3 minutes to start asking questions, okay? And again, using Wireshark, and it didn't take very long for me to start saying, wait a minute, this isn't right, there's something wrong here. And within a few instances, we figured out that one of the switches had been taken down, and the most vulnerable time for any device is when its RAM reloads and starts back up. They had been able to stuff malware in there. And we're seeing, Denny and I did a show last week, I think it was, Denny, about the hacks going on from overseas. Just recently, almost 1 million routers were shipped around the world, the United States and Europe, and every one of them had malware in it.
Wow.
And if you don't have any method of looking at your network, you're in deep yogurt today. And I think, was it Ponymon that said that the average breach is costing roughly $5 million, and now we're finding out that about 80-something% of breaches, when we think we've got them cleared up, that they've left a little venom or a little poodle or a little something in there that they can activate later. And if you can't see it, you ain't gonna know what's happening. You ain't gonna be able to fix it.
Yeah, that's true. Tim, you bring up a good point. Since we're talking about taps today as our featured product, one of the things that auditors use, network auditors, security auditors use quite a bit, is they keep them in their toolkits. So that, as you do, when you walk in, customer says, I'm having a problem, I don't know what's going on, the first thing the audit team will do is come in, insert a tap into the network, and begin collecting information. And one of the benefits of that is that because they're not, what he's showing us?
That's
there's a
my
tap
tap.
right there. When the auditors come in and deploy the tap, they don't have to bother the IT team with getting a span port or using one of the span ports that they've already got deployed. So they can, once they schedule downtime, put that tap inside in the links and then start doing their collection and analysis. So it's a very, very popular product with audit teams, just to kind of bring around in their toolkits and deploy them when they're doing troubleshooting. Again, just it makes it a lot easier for them to collect that data.
And the data act teams from different organizations around the world have switched away from doing anything with span or VACL or embedded, because it's not in their control. so they want a tap. And Kali actually calls out that you need a tap to get access to that part of the network for the warrant. And I think this year, Tim, we're going to see, I know we already have seen a lot of new laws, a lot of new legislation. I think within 2 to 3 years, we're going to have professional standards that will require people that are trained to be security people and are certified in that business. They're going to have the knowledge to deploy a visibility plane, I call it. That's because I'm simple-minded, but to me, we got all these other planes. We got data planes, we got connection planes, we got blah, blah, blah. We need a visibility plane so we can see our network, and we need a mobile one so if we have to go somewhere, we can do it. I mean, I don't know if you met Tom Tosh, one of our friends with Chi Metrics. He deploys a built-in system for troubleshooting remotely. Mm-hmm. And what you mentioned a minute ago just rang true. The first time Tom had to go on a trip, he said, "Can I borrow a tap?" And since then, he's bought 8 or 10. Yeah. And we see this, people getting into it. And I've always liked, I would love to see some of the good guys at Sharkfest, which, by the way, you're going to love. If this is your first time, it's incredible. You're going to meet some incredible people there. And get them to play with them. And once they do, they're like, wow. You know? So I just think you're going to have a blast.
I just wanted the one comment I want to make is relationship to auditing, network auditing. I remember having that conversation early on in my last company, and we were selling. Well, we weren't actually selling taps, but the conversation of taps came up, and we were selling into the auditing team, and it turns out that doing a network auditing is very similar to doing a financial auditing of your company. Sure. I mean, if you have auditors come in, you can't just give them the password to your accounting system. That doesn't work like that. They really don't want to have access to your data. They just want access to a copy of the data. So in other words, you hand them a copy of your books, not the book itself. Right. That's how that's how they do auditing. And network auditing is the same way. And it's very important to understand that a tap is essentially a passive device. Right. Even though a gigabit tap might require power, but it's a passive device. Whereas a span port is not a passive device.
That's right.
And also we're seeing with e-forensics now, and in law enforcement, they use taps because they don't want any ability to change the data. They just want the ability to capture everything and use that. And it doesn't matter if you use predictive analysis, e-discovery, or what you're doing. A tap, to me, is as essential as a slide rule. Wait a minute.
Hey guys, would it be okay if we cut it slightly, short today? I don't want this show to be too long because I really want to give people a chance to watch it. And if we go over 45 minutes, they're not going to do it. At least not during the weekdays. Yeah. So with that, I want to thank again to Mr. Crofton for coming to the LMTV, and I hope you have a great time in California.
Will do. We're looking forward to being at our first Sharkfest, so stop by and see us if you're out at the Computer History Museum.
Okay, and I noticed that you collect movie titles, show title, everything to do with tap. So I was just curious, so I went online to see if lockmytool.com is still available. Of course, it's not available, but it does belong to a microbrewery in Missouri.
Ah.
Okay. That makes a lot of sense. So just in case, okay?
Okay.
And next time when you happen to be in that part of the world, you ought to listen to. Yeah.
Thank you. This is great. We got to keep this conversation going. This is an essential conversation for professional management of networks and for security in networks. And today, that's the word, security.
Yep. Well, I appreciate the opportunity to be here, and thanks you guys for having these types of conversations to help customers improve their network visibility. Thank you very much.
Okay. Thank you, Tim. And thank you, Mr. O'Neill.
Mr. O'Neill.
And with that, we'll see you. Well, actually, we'll see you tomorrow. We have another LMTV Sharkfest, and this time it will be with Garland Technology. So, with that, thank you very much, and see you soon. Bye bye.
Thanks, guys.
Hey, Tim, that was great. Thank you.